Welcome to the webinar about our new product Cabinet Guard. My name is Carsten Bockhold. I'm responsible for product development at Helmholz. And in the next 30 minutes, I would like to introduce you to our new product Cabinet Guard. More control, more security with the Helmholtz Cabinet Guard. What is this all about? It's about protecting your cabinet. And the control cabinet is the heart of your machine. So, if you have a machine and you're working with predictive maintenance, or you try to get the data from your machine for digitization, the main focus of all this is going to the sensors or to the actors, to the drives, to the stuff which is outside the control cabinet. But if you want to have a whole picture of your machine, of the situation of your machine, and you want to see if the machine is healthy, you also need information about your control cabinet, because in your control cabinet you have the most vital parts of your machine. It's a CPU, it's a power supply, it's all the sensor analyzing parts, it's controlling the drives, and everything is in your cabinet. So your cabinet itself is really important for your machine. And so we said it's the heart of your machine. Could also be the brain of your machine, but I think heart of your machine sounds better. Okay, so let's start. What is the danger which can come up to your cabinet? The hazards. It's the temperature. I know you have, most of your cabinets have some ventilation systems or some AC inside, but the temperature is important. Humidity is a big topic depending on where your cabinet is sited. Unauthorized access is really important, especially if you check the new law about Cyber Resilience Act or machinery regulation here in Europe, or even outside Europe. You have the discussion about security of your machine, and accessing your cabinet by unauthorized people, it's a risk on the machine function and on the security part. There's also a topic, mechanical stress, so vibration or shocks. Most cabinets I know will be positioned somewhere inside a factory and locked on the concrete of your factory floor. But even then, it's possible that a forklifter is colliding with your cabinet because the position is not so perfect, and you want to know what's happening in your cabinet, especially for cabinets which are positioned or mounted on movable devices. The quality of the power supply is also important to know. And this is a situation in the control cabinet introduced by the outside. So you have temperature from the outside, humidity possibly from the outside, because you have factories which are have cleaning or something like this. And it's also the possibility that the cabinet itself has hazards because of slow degradation. So, for example, if you have a contamination of your AC filters or of your venting system or stuff like this, you will get slowly a higher temperature until the point where the temperature raises above the limits of your system. And corrosion could be a problem, and also wiring errors. If you have a wiring error of power supply which has a big power in the cable, you can have some let's say temperature changes or other stuff. And there's also a big topic we're discussing with our customers, because this idea, the cabinet guard, is an idea, it's not coming from ourselves, it's coming from our customers. They ask us to get, they need something like the cabinet guard we have here designed. This is hazards during transport. And if you set up your cabinet and build in all the parts and do the wiring and or even do the testing of the cabinet, then normally you do the transport after it. You put it on the truck, you put it on the train, you put it on a ship to get this cabinet to the location where it's needed, where it has to be installed somewhere in the world. And this transport is also a risk for the cabinet, because it can fall from the truck, the forklifter moving it from the truck to the train, let it fall down or something like this. And if you receive the tested cabinet at the factory site and you get information about what happens on the road, it could be really interesting before you start to switch it on or to install it. So all these headers, all these information we wanted to collect, these topics from our customer requests lead to the product cabinet guard. And the cabinet guard is show you the design of the product. We have a small distance sensor, which is from the technical part, it's a time of flight sensor for the door monitoring. So this distance sensor is measuring the distance to the inner side of the door, and you can take this, the standard distance, as a standard value. And if somebody is opening the door, the distance is getting higher, and then you can activate an alarm. We have the environmental sensors, air pressure, relative humidity, temperature, vibration, and movement, all built in the cabinet guard. And you have all the sensors inside the device. Then we have two extra external NTC sensors for measuring the temperature outside the device. Outside could mean inside, somewhere inside the cabinet, for example, on the top of the cabinet. But you should also take one sensor outside the cabinet to have a relative information about what is the temperature outside and on the side, on the factory building, and in comparison to the temperature inside. And for example, if you have outside 0 degree because it's cold and inside 60 degree, then you know, okay, something is wrong because the difference between 0 degree and 60 degree is really high. Then we have some digital IOs. We have outputs for alarming. So you can, if you have some alarms in the device because of temperature, because of air pressure, humidity, stuff like this, or even the distance sensor, the output will be switched on. You can use it as a contact to wire it somewhere else. And we have some inputs you can use for more information. Like if you have a bigger cabinet and you want to know if the second door is also be opened or if a third door is opened, you can use contacts, door contacts, and connect them to the cabinet guard. Or if you have an air conditioning system inside, they usually have outputs for faults or for errors. So you can contact this information from your air condition or venting system directly to the cabinet guard and use this as alarming or information. Yeah, we have the Ethernet connector. This is a communication device. We have a web server, I will show you later, and we will send all the data and alarms and stuff we collect here over MQTT to high-level systems, or you can fetch the data by Modbus TCP from the cabinet guard. We decided not to implement at this device a Profinet or Ethernet IP because our design was meant to be used on a high-level system. This is not a sensor for the PLC. It's a sensor or condition monitoring device which should be connected to higher level systems in your network. We also have voltage measurement in the power supply, so you can analyze what the power supply is doing, if the voltage is slowly going down or it has some spikes. So you can also see this. And at the back of the housing of the device, we have a slot for a memory card, as a micro SD, for recording measured values over a longer period. And you can fetch them over web interface, or you can unplug the card, but normally you go to the web interface and download the file, which is a CSV file, and analyze the data in more detail over longer time logging. And the size is really small. You see it from the connectors. It's only 2.4 centimeters wide, 5.5 centimeters in a depth, and the height is 10.9 centimeters. So it's really small. Yeah, condition monitoring in the cabinet. This is what it is. and pocket size digitization. So it's not only monitoring, it's also needed to make all this, digital twin digitization needs some customers have. So they want to have more information. For example, we have customers, they want to use it on many similar cabinets and then see from the values if the cabinets are working in a different way. If they have cabinets with the same hardware inside for the same purpose, for the same machine, but if some machines are working in a different way, getting warmer, changing temperature or humidity, and then to compare the different machines. So it's also the possibility to use this device. Okay, so this is a impression of our web interface. If you enter the web interface, you have to log in. We have a user management inside, and then you have this main view, and you see all the values. For example, you have this internal temperature, pressure, humidity, the distance, the one external temperature. This is for my setup here, and some voltage and some other information. So let's go deeper into the different sensors. Let's start with the distance sensor, which is on the top of the device here. The distance to the control cabinet, to the door. And normally you measure you install the device inside the cabinet. You should use the side of the cabinet where the door is normally open first. You normally have not two doors. You have to open the first door and then the second door. Some of the cabinets are working in this way, so you should use the door which has to be open first. And then you measure the standard distance if on the situation if it's closed, and then you set alarm values. For example, you have 33 centimeter to the door, and then at 35 centimeter or 36 centimeter, you set an alarm. So if somebody is opening the door a little bit, the alarm goes. And we also have a low alarm, a minimum alarm. This is needed to have the information if something is blocking the way from the distance sensor to the door. For example, we had control cabinets and they had inside some cables from the inner side of the door, and over in each way you close the door, the cables are falling down a little bit, and then they are blocking the view from the cabinet guard to the inner door. So you have an alarm if something is blocking the way inside. It's less. For example, you put it to 25 centimeters, and if something in between, you also get an alarm. Additionally, you can have digital inputs for the door contacts. As I said, digital inputs can also be used as additional door contacts. This is, the need is protection against unauthorized access. So you get an alarm if somebody is opening the door, but nobody is allowed to do it. And this is for security reasons, it's important. And you have an alarm acknowledge system. So you get the alarm, and the alarm can be permanent until you acknowledge it. But we also have the possibility to disable the alarm at authorized access. So you can connect the key switch to the inputs, and if somebody's coming with the correct ID or key or whatever, he can switch, for example, maintenance mode, or you can do it by web access. Also say, okay, now it's maintenance mode, and then the alarm will not go on. The next is temperature and also humidity and all the stuff behind the temperature. And for this, you have a small hole here in front and also on the back of the system. So we have the through going air and pressure. So we can measure the internal temperature, and the internal temperature of the device is not the internal temperature, because everybody's asking, but you have a power supply inside and the processor, and this is heating. This will be compensated. There's a compensation about the own heat of the device. So this temperature is as precise as possible, the temperature which is at the device from the outside. But we also have external the possibility to connect external NTC sensors too, and they can also be used as extra temperature values. And the units can be changed. There's a possibility to set up to make the settings of the temperature. And you see it here. You can enable or disable the sensors. You can change the measurement unit. You can give each sensor a comment, a name, whatever. And then you have the thresholds and if the alarm is persistent or not. So this is the setting of the sensor. It's also on the web page. Yeah, you have the limit values, and you also have the low and high peak display. You see, in my situation, the room was up to 28. It's my office here. The cabinet guard is directly on my left side here. The high peak 28 degrees. It was a time in the morning and before noon, the sun is shining in my window, and it's a little bit warmer in here. And the low peak was 20 degrees. It's in the night, I think it was. Okay, so the next is the vibration, shock, and movement. And yeah, we have this special sensor inside, which is able to collect so many different data about movement, vibration, and stuff like this. And the most complicated point is to analyze all this stuff. And the easiest way to analyze this information is to check if we have a shock. Shock is a short impact or a strong braking. So if you have a moving system, you can set up the values that you say, okay, normally you are braking with 0.1 G, slowly decelerating. But if you just do a hard braking, for example, you have a moving device and something is blocking, then you can get an error. So shock or impact, you see this is here. You get if you have a shock, like if I'm just bumping at my housing here of the device, I will get a shock, and this gets the information here. And the next is vibration. So you get the amplitude and frequency, fast Fourier transformation, and you have this spectrum here. And you see you have different frequencies and different amplitude. And then for each axis, you can see it. And you can see if something is going on. So if you have like this with 0.35 and just one normal line, it means nothing is going on. There's a little bit vibration here because of my PC and the fan is moving. But if I would somehow put a motor nearby the system and the cabinet or my setup is moving, you will see a different layout. Yeah, movement itself, amplitude, velocity, displacement. This is more information about if the device is somehow shifted in one direction or another direction, and how far for the situation, and how high is the amplitude. And this is not implemented at the moment in the firmware. Will come some of the next firmware is tilting. It's also interesting because normally you will put in the device in an upright position on your cabinet, on your DIN rail. But we have some situation where we say, okay, there are some moving parts, and the moving could also be a tilting. We have customer building cranes, especially for construction sites, and these cranes should be even on ground with the stabilizers. And if something is happening and the crane is a little bit tilting, then you get an alarm. So it's also possible. Yeah, and all this is on 3 axes, independent. So you have the information, for example, for the tilting can be the Z axis and the other axis for the tilting, or you have the movement in the different directions. And yeah, okay. The next is we have all this information, and you can take a look on the web page and see all this. But it would be interesting to get this information to somewhere else, because we do not want to go always on the web page and take a look if something happens. So we prepared communication possibilities, and one is, as I already said, the MQTT. So the device is able to send MQTT frames with all the values, all the data packed inside the MQTT frame. And we have a short snippet here for the temperature, for the internal temperature. You see, we get the information if the sensor is active, and the comment, the name of the sensor, the actual value, alarms, the type of the sensor, upper limit, lower limit, high peak, low peak, and so on, the unit, and the timestamp from this value which was sent at the moment. And you have the possibility to connect it to the MQTT broker. You can send the data to a local MQTT broker. So we also have a MQTT broker to build inside the cabinet to use it for this purpose. But you can also send it to the cloud and to the cloud MQTT brokers to do some high-level cloud analyzing of the data. The publish interval can be changed. The minimum interval is 1 second. So the device is not able to send, for example, vibration information each 10 milliseconds. This is not possible. The device is too small and the core inside. So it's more a matter of, did something happen in the last second? So it's more information about, did something change in the vibration? Did something happen in the last second? So it's not about logging data in millisecond framing. You can use authentication for the MQTT and TLS encryption, so your data is also secure on the line to the next broker or to the cloud. And if you do not want to use MQTT, you want to get the data as information for your high-level PLC or directly for the PLC inside your cabinet, you can use Modbus TCP. Very simple. All the values and all the information, not only the values, all the information is inside a big list of Modbus TCP registers, and you can get this information and read it from your PLC into your PLC. Coming up to the logging, we have this micro SD card. You can plug in at the moment up to 32 gigabyte micro SD cards are possible. All the data from all the sensors will be logged and stored in an CSV. Also on this 1 second cycle, you can download the CSV file or the parts you're interested in and analyze it with other software. And what we want to achieve in one of the next firmwares, which is a little bit not easy to do, but we are on the road, is logging during transport with an external battery. And at the moment, you can use the device already with a battery. It's no problem. Take your standard car battery with 12 volt or some 24 volt or whatever you have, and use it with the cabinet guard. The problem is that the cabinet guard at the moment needs a little bit less of 1 watt, and then you can use it only for a couple of days with a bigger battery. And our goal is to implement low power mode in the firmware, so the device is sleeping the most time and just waking up each second to make a new measurement, or if some interrupts come from, for example, the movement devices, because this is the most important part: mechanical stress on the way to the final factory, on the ship, on the truck, on the train, extreme temperature, humidity, and you can collect all this data. But in between, the device will go sleeping to preserve energy, and then we think we will get up to 8 week, 10 week with a battery you can put inside your cabinet. So you should see the web interface, and I do the login. So, and then you see the web interface of the device. You see all the values. You see also the difference between the internal temperature and the external temperature. The external temperature is an NTC sensor, which is somewhere in on my wall. And the difference has a reason, because the device itself is surrounded by other devices, and these other devices already pumping the temperature up in my not so close cabinet. And so you see the difference. And for the distance sensor, it's just looking behind me to the next wall. So it's the distance is too far to measure anything. But if I take a block and block it, you have, for example, 50 centimeter, and after 50 centimeter, you get an alarm. So this is door closed, and door open. So you have the situation. And the cabinet guard itself also has LEDs in front, so you get also an blinking orange alarm LED, so you see that something is wrong. And what else do we have? We have the settings. You can also switch it to German from English. You have the sensor settings to set up all the values for each sensor, temperature. For example, you have pressure. I used hectopascal as a unit, but you can also use Pascal. Humidity, distance sensor with the low and high values. The amplitude, frequency, the temperature is here with some low and high, and also some beta and omega values, ohm values, to do some adaptation if you have special sensors, and yeah, everything else. And then you have the network information, just the IP addresses. You have the possibility to make a firmware update for sure. And here is actually no SD card mounted. And then we have this vibration information page. And you already see we have some low amplitude frequency going on here. And there's some amplitude. This is the vibration matrix, velocity, amplitude, and displacement. And at the moment, we do not have any shock. I will try to make a shock. You see, I just bumped in the housing, and you see I got a shock in all three axes, so it was a good shock. You also saw that this was also a little bit higher and on special frequencies. Yeah, so this is what we have. And the point is, there are so many different situations or so many different ways to do interpretation of this FFT spectrum or the amplitude or stuff like this. It depends on what you are looking for. And we are in discussion with many customers to say, can you please bring up one more graph or a different view on this vibration sensor? I'm interested in seeing this or that. So this is what we are working on, especially that the different use cases of this vibration sensors coming up from different customers. Sometimes you want to see if the vibration over time is getting higher and higher because your mechanical connection between the drive and your machine is getting worse and worse. Something is moving, or you have, for example, we have customers who want to implement this device on a ship, and they want to measure the vibration, and then over the time of the vibration, they want to fix the maintenance point where they have to check all the cables and the connections in the ship, because a ship is always vibrating, but it's depending on how long, how much, how extreme the vibration is over the time. So you need the logging, you need the information over time, and not one chart saying what's happening at the moment. So this is a really complex thing. We have all the values. The point is how to use them, how to analyze them, and the best way is to take the logging and do analyzing it on a daily base or weekly base or whatever. Okay, so we have also user management. At the moment, it's only the admin installed here, and we also have the possibility to download or upload the device configuration. So if you have many cabinet guards, you are setting up all your sensors once here, and then you can copy this configuration to different cabinet guards and send them to install them in the different cabinets. And yeah, here is cloud protocol activation, Modbus. At the moment, Modbus is off. You see the standard stuff here. Time settings. This is really important to have a correct time, because of the logging, because of all this sending information over MQTT. So you should have somehow a time. Okay, so yeah, that's it. I will just jump back. Yeah, that's it. Protect the heart of your system. Cabinet guard, monitor, report, protects. So you see all the features of the device. And yeah, it's a small device. It's a not so expensive device. The list price here is 279 euro. So all the sensors, all the possibilities in one small device, which you can design in your cabinet or even do retrofit in existing cabinets. And you get the values, you get the information about your cabinet from the environmental sensors or the security and monitoring. Yeah, this is, I think, a really interesting device. And we have this device as it is at the moment. There will be some more features coming up in this device. You get the firmware updates, which will be without any cost. So we will implement some more features. But we already have many, many ideas from customers which are going beyond the technical possibilities of this device. And we are already working on a Cabinet Guard Plus, which will have more features, more possibilities. Yeah, but this is the beginning of a product line for condition monitoring and all this information gathering. Okay, so yeah, that's the end of my list. I have yeah, we have some no questions, some hints, which is interesting, and some thank yous. Okay, thank you for your things. Here one new question: how many inputs outputs does it have? So we have 5 inputs, but 2 of the inputs are used also as outputs. So you can have, for example, 1 output for alarms and use 4 inputs, or you can use 5 inputs and you do not have any outputs, or 2 outputs and 3 inputs. So 2 of them are switchable and 3 inputs are always there. So you can have up to 5 inputs in this device. Okay. Yeah, release date, a good question. We already have it released. The manual is on our webpage. You can download it, you can read it. We have sent out the first bunch of devices, the first hundreds. And today I heard we will have more on stock in the next days. And it's released. You can have it. We will do some more implementation of some more features. For example, we plan to do an email service inside the device to send emails upon alarms. You will have some more detailed features on the digital in and digital out and stuff like this. Yeah, the device is a DIN rail mount. It's a question, and it has a really, let's say, more concrete mounting. It's not a plastic mount; it's a metal mount because to have a good connection to the DIN rail. I think your question you can see here. This is a plastic one from our drivings, but at the moment we have a metal mounting. This is only a design here, and it will be mounted very thoroughly on the DIN rail to get it really strong on the cabinet, so you can have the vibration. Okay, these are the questions. If you want to contact me, you can send to our support at helmholz.de or helmholz.com. They can answer all the questions to the device, and you can contact our sales if you want to have, for example, an example device or something like this. So, and if you have more questions, just contact us. Okay, that's all from the questions. So thank you very much. And yeah, I hope this is interesting for you. We know some customers in the beginning, they think about the possibilities, and step by step they see what's all possible with the device. And yeah, I wish you a good day, a good afternoon. And as I said, send us questions if you have, and we will answer them. Thank you very much.